In this video, I'm going to go through some properties of exponents and logarithms. So starting with exponent properties, let's suppose we have u cubed times u squared. So first, if we just write out what that means, so u cubed means u times u times u, and then u squared is u times u. So we don't need the brackets here, so we've got u times u times u times u times u. We've got u multiplied 5 times. Okay, in general we don't need to expand like this. We can just use the property that if we're multiplying two powers of a variable u, then we can just add the powers together, add the exponents. So in this case 3 plus 2 comes to 5. So our answer is u cubed times u squared equals u to the power 5. For number 2, again, let's just write out what it is first. So we've got u cubed in the numerator, u squared in the denominator. So I can cancel some of these u's like this, and we're left with just a single u in the numerator. But again, we don't really need to write this out because we can just use the property that if we're dividing one power of u by another power of u, we can just subtract the exponents, subtract the denominator power from the numerator power. So 3 minus 2 is 1, but that's just u. Number 3, again, let's write out what this is. So it's going to be u times u times u times another u times u times u, because we're squaring u cubed. So if we count up how many u's we have this time, we've got 6. Again, we don't need to write this out in this way. We can just use the property that if we're taking a power and then another power, we just multiply those two powers together, those two exponents together. So 3 times 2 in this case is 6. Number 4, it's not really a whole lot we can do with this one, but we can recognize that we've got uv times another uv times another uv. So we have u cubed times v cubed. So that's pretty much all we can do with that one. The next one, number 5, we've got u cubed in the numerator and v cubed in the denominator. So again, there's not a lot we can do with that one either. What about number 6, u to a negative exponent? Well, that's defined to be 1 over u to the positive exponent. So u to the minus 3 is equal to 1 over u to the 3. Number 7, what about a fractional exponent? So another way of writing this is as the 4th root of u. So u to the 1/4 is the same as the 4th root of u. U to the 1/2 would be the square root of u. U to the 1/3 would be the cube root of u, and so on. What if we've got number 8, u to the 3/4? So here we've got the 4th root of u cubed. So the 3 in the numerator remains as u to the power of 3, and then the 4 in the denominator of the exponent. Remember, in the previous example, u to the 1/4 is the 4th root. So here we have the 4th root of, in this case, u cubed. And then number 9 here is just an identity, u to the power of 0. Well, anything to the power of 0 is 1. Moving on to logarithm properties. So if we start with an exponential function, if we take the logarithm, the base b logarithm of both sides, we would have the logarithm of v equals u. So these two are equivalent equations. Number 2, if I was to take the base b logarithm of b to the power u, I would just get u back. And the second part of this one, if I have b to the power, the base b logarithm of u, again I just get u back. And then number 3 here, if I take the logarithm of u raised to the power 3, I can take the 3 outside as a multiplier. So I end up with log 3 times the base b logarithm of u. Number 4, if I've got log of u and then I add the log of v, and we're using the same base for both logarithms, then that's the same as the base b logarithm of u times v. And number 5 is similar. If I have the difference of two logarithms, then I can write that as the logarithm of u divided by v. Number 6 is an identity. The logarithm of 1 is 0, no matter the base. And then number 7, if I take the logarithm of b, if b is the base, then that comes to 1. Just a couple more things to note. It's very tempting to think that the logarithm of u plus v might be logarithm of u plus the logarithm of v, but that's not the case. These are not equal. We've already shown what the logarithm of u plus the logarithm of v is up here, and it's not equal to the logarithm of u plus v, it's equal to the logarithm of u times v. And then similarly for this next one, it would be tempting to write the logarithm of u minus v as the logarithm of u minus the logarithm of v, but we know that's not true because we've already seen up here in number 5 that if we take the logarithm of u minus the logarithm of v, we get the logarithm of u divided by v. We don't get the logarithm of u minus v. So there's actually nothing we can do to simplify the logarithm of u plus v or the logarithm of u minus v. So those are some properties of exponents and logarithms.